This is our kit for study of Lissajous figures. The kit consists of two audio oscillators having variable frequencies of 0 to 10 kilohertz and two variable amplitudes of 0 to 10 volt peak to peak. This is the first audio oscillator output and this is the second audio oscillator output. An RC circuit has also been provided on board in order to study the magnitude and phase angle relationships between two signals having the same frequency. And we also need a DSO or an oscilloscope in order to study the signals and the phase relationships between them. We have a detailed manual here which gives details of all the Lissajous figures that can be obtained. There is the procedure on how to obtain the Lissajous patterns on the oscilloscope screens, and also how to change the phase angle of the two signals in order to study their relationships. So we will just simply connect the first channel of the DSO to the audio output and the second channel will be connected to the second audio output. We have switched on our kit and I've set the screen in such a way so that we can see both the input waveform and the output waveform. This is the channel 1 and the channel 2 signals, and also the XY mode we can observe at the same time. So now let us switch on the kit. So here we have two different frequencies and we can also see the Lissajous pattern on screen. So the first channel has a frequency of 1 kilohertz and the second channel has a frequency of 2 kilohertz. So we can see that the second frequency is twice that of the first frequency, and for that we obtain a figure of 8 like this, and we have used the stop button here in order to stabilize the signal, as you can see here clearly. So now we have adjusted the second frequency so that it matches that of the first one. So both the frequencies are now almost equal, as you can see. This is the kind of Lissajous figure that we obtain on the screen. So these are all for a phase difference of 0 degree. As we can see, there is almost no phase difference between the two signals over here. So if we increase the phase difference, then we will obtain different patterns. Let us now change Fy, which is the second frequency, so that it is half of Fx. So right now Fy is half of Fx, and this is the pattern that we obtain on screen. You can also, for reference, you can also see what kind of patterns we will get. For example, we are at Fy is equal to half Fx and we are getting a pattern of pattern like 8 for phase 0 degree, and that's what we have obtained on screen. Now we have changed the frequency so that Fy becomes 1/3 of Fx. So Fy is 1 kilohertz and Fx is 3 kilohertz, and we will just press the stop button in order to see the pattern on screen, and this is what we get. And if we just compare with this, Fy is 1/3 Fx. This is the kind of pattern that we are getting. And as you can see, there is a phase difference of 90 degrees in between the two waveforms. We'll just try to, so that is why this is the kind of pattern that we are getting. So this is the pattern. So likewise, we can change the values of the two frequencies, and according to the relationship between the two different frequency signals, we will get patterns on the screen. And from the horizontal and the vertical axis, we can find out the frequencies of two waveforms just from the Lissajous pattern, and that calculation is given in the manual over here. So now I've connected the circuit in order to study the phase and the magnitude relationship. So what I've done is I've just connected the audio output over here, and I've connected the channel 1 of the CRO over here, and the channel 2 of the CRO goes over here. And I've adjusted the frequency so that we have got a frequency of 1.2 kilohertz, and the phase difference between the two signals is almost 45 degree, and that is why we obtain a figure like the one shown. And if we compare it with here, for fx equal to fy and 45 degree angle, we get a figure like this. Now in order to change the angle to 90 degree or 0 degree, we just need to change the value of the resistance R1 and find out the different figures that is generated. So this concludes our experiment, and this is how we can obtain different Lissajous patterns on the screen, and we can study the relationship between two frequency signals and also the phase and the magnitude relationship between the same signal as well. Thank you.
Please subscribe to our channel to get more such videos. Thank you for watching.